So we're going to take a look at some selected solutions from 5.3. And I've already pre-done the problems, so just try to save you some time in watching them. I really advise you to look at and understand the explanation I'm going to give. So first one we're going to start with is number 2. When I look at number 2, what I'm going to do is I'm going to start by looking at the denominators. And so when I think about the idea that this thing has everything, the question is, what does this need now that it doesn't have? It doesn't have the 4 or an additional x because it needs to be x squared. The other one has a 4, but it's missing the x squared, so you can see I multiplied that in. And I also recorded that the domain restriction is x is not equal to 0. Think of the domain restriction as the answer is not allowed to be this answer. All right, so I'm starting at the bottom of the order of operations. I'm working upwards. That's why I started with a common denominator, because when we learned in 5.2 that when we do addition and subtraction, we're really looking for the common denominator. So I need to combine my like terms. Now that I have my like denominator and I've simplified the numerators, I just write down my numerators. There are no like terms, so I just combine them into one thing. And now I'm about ready to do the step right here, which allows me to multiply by the common denominator, which is an excellent step because it cancels the denominators out. In fact, if you've done this enough and you understand it, you could literally just cross them out, okay? But I want you to understand it, to show it to me on your homework that you did it a couple of times, and to save space in these boxes, you may just cross it out once you have combined like terms. Remember, you have to finish this step before you do that step. So once I get to here at this point, right, when I get to this place, at this point, I now have old stuff, right? That's where our old stuff is. And that's going to be a quadratic quite frequently. Sometimes it is not. So what I do there is I set it equal to 0 by moving the terms that do not make the lead coefficient negative. I always get a nice factorable quadratic. This one factors in the 5 minus 1 to get 4. And then I set those equal to 0, so my actual answer is -5 and 1. And if you plug them back into here, you will get a fourth. Like if you want to put those in Desmos, it's pretty easy to put the 1 in there. 5/4 minus 1 is 1/4. So yeah, those work. You want to check your domain restriction to make sure it doesn't cross them out. And in this case, the domain restriction is a good thing because it doesn't interact with any of our answers. So our answers are both -5 and 1 in brackets for a list. So the next one I looked at, that's the basic idea, was number 5, because a lot of students, it's involved. It's one of the longer problems. So what you do is you look at these two things and you say, well, you don't ever want to do this. Look, as a student, you never want to take this whole thing and put it over here. Notice it's not there. You never want to take this whole thing and put it there. So what I did is on the first one, okay, is I factored out the denominator. Not so it'll cancel, but so I can figure out what it shares with this denominator. So I factored this out with the GCF, and I realized that both share a 3. So I need to multiply the x plus 2 from over here, right? That blue x plus 2 goes here and on the numerator. The x minus 3 goes here and on the numerator. And then, unfortunately, I have to stop and use the box method because of this coefficient. When there's a coefficient, I can't do that quick little adding, multiplying trick. I actually have to write it out, x minus 3, 2x plus 4, figure out all my box elements, combine my like terms, and then I get my numerator. Same thing over here. I have my 4x plus 8, my x plus 2, figure out all my box elements, and then I combine my like terms, always on the diagonal, as we learned earlier in the year, and I get my numerator. Then I can multiply through that. And again, if you just want to cross it out once you've combined like terms, that's cool. So then I get two quadratics equal to each other. I'm going to choose to solve for this side, right? I want to solve over here because if I subtract 2 from 4, I'll have a lead coefficient that is positive. Once I do all that and I zero it out, a lot of kids freak out because they're like, oh my goodness, I have a 2 on there? I mean, hypothetically, you might have to use a box, but this GCFs, 2 comes out of 2, 18, and 28, leaving me with 9 and 14, leaving me with 2 and 7. So I set those equal to 0, and I get -2 and -7. But you always have to be aware of the domain restriction. The domain restriction is that x cannot equal -2 or 3. Remember, that's the answers it cannot be. And so when I come down here and look, I should have like that face, right? That's not allowed. So that one gets crossed out. And I keep only this one. This is my only valid solution in my answer. All right, one more solving problem, and then we'll look at an inequality. So when you come down here, a lot of students, again, you do not want to ever take this quadratic and start multiplying it in multiple places. You take that quadratic and you factor it out, okay? So I factor this quadratic out to show me that, oh, look, those are my other things, right? So I take the x minus 1 part here, and I multiply it here, all right? And then I take the x minus 6 part here, and I multiply that over there. So that is luckily, that's just a nice little easy distribution, 3x times x and 3x times -6. That gives me 3x squared minus 18. Here, that's a little bit hard to read, but I'm multiplying 2x times x and times -1, so I get 2x squared minus 2x. This just drops down. That's why I left it in that color, okay? And so then I combine my like terms, 3x squared and 2x squared to get 5x squared, and then -18 and -2 make -20. My canceling the denominator step. And then when I try to start solving this, I actually cross out my quadratic term. So I move these two over here, and it cancels here, and this cancels. But then I cancel out my quadratic term, and that makes students feel uneasy all the time. Don't feel uneasy. That makes your life easier. This is now just an Algebra 1 solving equals 0 problem. Remember to move your letter to the right, to the left side from the right to the left. Letters need to be on the left, and you divide by 20 because you have this 20 left over here. And so you divide by 20, and you get the answer of 1. Now, please watch out for your domain restrictions, because my domain restrictions, as you can see, are that x can never be -1 and 6. Sorry, +1 and 6. So if I come down here, right, it said it can't be 1 or 6. I should have a really weird what's going on, right? There's no solution here, because the only answer I got was a domain restriction, and that answer is now gone. Please keep in mind on the SOL, they use the set of nothing or the empty set. Okay, and also on the SOL, I have seen, more likely on the SAT, I've seen this symbol to mean empty set as well. So why do we need to make sure we keep those letters on the left? Let's look at our first inequality. So if I look at this inequality problem, I'm going to be solving it very similarly. I try to make the problem very easy in the sense that I just let it equal an integer. And so you multiply by the common denominator of just x minus 1. You don't need to put the 1 over here. Obviously, that won't do anything. So then I distribute my -1 here and here, and I get -x plus 1. Please watch your negative multiplications and don't make a boo-boo. If you get to the end and the problem is not easy to solve, you made a negative error. That applies to this, and like, can you imagine, like if we looked at this problem, you get all the way to the bottom of this thing. If this does not factor, you made a little error somewhere. Please double check. All right, so back to this one. We multiply, we distribute, we make sure we don't make an error. At that point, you're already ready to cross out your denominators by multiplying on both sides. This will drop down, 2x plus 1. This will drop down, and then you have an Algebra 1 problem. Please put your letters on the left for the inequality, or the inequality will be backwards. So I moved my x over here and got 3. I moved my 1 over here and got 0. This is the reason I did this problem. Students still get confused sometimes. If I divide anything into a 0, I get 0. And you can see that x greater than or equal to 0 is one of my answers, okay? So you have to be careful, but there's a domain restriction in the way. So you actually don't see this answer down here. And this is why I wanted to make sure I went over it, because it's interrupted by the domain restriction of 1. So the domain restriction is that x is not allowed to equal 1, and that has to go on my number line analysis with the 0. So the 0 gets a solid dot, the 1 gets an open dot, and then I start checking. I'm going to use -1. You can use 10, whatever you want to do. If I take -1 and put it into here, I get -2 plus 1, which is -1. And if I put -1 in here, I get -2. So the two negatives cancel out, and I get 1/2 is greater than -1, which is valid. Please be careful that you understand that this was actually -1 over -2, and the negatives canceled out. Those negatives are going to haunt you. We don't mention it up here. It's down here. Please be careful. So I'm going to skip over this middle one because it gets complicated, just because you have to plug in a half. So we'll talk about how to do that in a minute. But over here I plugged in 2. Could plug in 10 if you want. Well, if I plug in 2, I get 4 plus 1. 4 plus 1. If I plug in 2 in the bottom, I get 2 minus 1, or 1. So you can see here that I got 5 is greater than -1. That's true. So that's the valid part of this answer. It is valid from 1 to infinity. But if you check out a half, between 0 and 1, you can pick anything. If you wanted to, you could pick 0.1 if that made you happy. But I picked a half. The reason I picked a half is 2 times a half is 1. So 1 plus 1. And then on the bottom, you just get 1 half minus 1, which is negative a half. And this would reciprocate, as we've learned in this chapter, and then multiply, giving you -4. And -4 is not greater than -1. That fraction is a lot to analyze. So don't forget, if you want to, you can also use Desmos. Notice what I did here was I put in a half as my checking point. And then I typed in the original equation, 2x plus 1 over x minus 1. Don't forget when you're typing to actually click here and then divide. If you don't, you'll see on your screen it's not right. So I got -4 is greater than -1. And this would work for anything in here. If I wanted to use 0.1, I get -1.3. And -1.3 is not greater than -1. It's less. Obviously, the 1/2 makes the most sense because it comes out to an integer. And that's why I picked it. So to look at the actual answer, you can see, negative infinity to 0 with a solid bracket, right, with a square bracket. Negative infinity to 0, square bracket is valid. And 1 to infinity is also valid. But you would never know that from this answer. That's why the domain restriction is so important to include on your interval. It doesn't necessarily cancel the answer out, though it may, but it's not going to happen. I'm going to make it so you have to check it. It just provides additional answers. Like, for instance, who knew that this would be valid? And also, this was valid, but not until 1, which is the domain restriction. So make sure you have your negatives correct and your domain restrictions on your line. All right, let's look at one more that comes out to a quadratic. I'm going to zoom in on this so it's a little bigger. Okay, so here we go. In this problem, again, I try to keep this first step simple. Put a 1 on the bottom, I multiply by x plus 1 on both sides, and then I distributed my 2x, my 2 times my x, and my 2 times my 1. I then did my multiplication and division step to cancel out the denominator. I now have a quadratic. Big surprise. There's always old stuff after the new stuff. I then move everything over, and I get a quadratic. It's one that kids forget all the time. 1 times 1 is 1, and 1 plus 1 is 2. And if I make them both negative, it'd be -2. So the factorization is a double root. Remember that idea from last chapter. So x minus 1 and x minus 1 are the factors of this. They both provide x equals 1 and x equals 1, which again is a double root. Not significant other than the fact that I'm only going to put it on the number line once. Now, why does it have an open circle? Because the one I just had a minute ago had a closed circle. Because the problem right here, right? The problem says that, hey, that right there is less than. It doesn't have an equal sign, so it will be open. I have a domain restriction at -1. So those are always open regardless of the problem. So I put that on there, and then we start checking. So if I check -2 into the original problem, I would get -2 squared, which is 4, plus 3, 7. And then -2 on the bottom would make -1. So I get 7 over -1. So is -7 less than 2? -7 is a negative number. 2 is a positive number. Check, that's valid. Then I'm going to check 0. It's the only thing that's reasonable between -1 and 1. You can check whatever you want, but 0 is very reasonable. So 0 in here would give me 3 over 1. Is 3 over 1 less than 2? False. So big fat no. And then after 1, I pick 2. So if I put 2 in here, I get 4. I get 4 plus 3, which is 7, over 2 plus 1, which is 3. So 7/3 is not, right? 7/3 is not less than 2. And some kids get uneasy. They're like, what? Check x. You could even try x equals 10 if you wanted to just make sure that this is not going to be less than 2. So if I put 10 in here, I'd get 103, right? 10 squared is 100 plus 3. So I'd get 103 and then divided by 11. That is clearly much, much bigger than 2. So yeah, it is check XX. That does happen sometimes. And so your answer comes out to be negative infinity to -1. It doesn't even have anything to do with these solutions, though you had to check it. That's why that domain restriction is so important. So to wrap it up, make sure that you spend most of your time in this step, right? And just make sure that when you cancel out your denominators, you know what you're doing. Then you're going to old stuff, almost always a quadratic. Sometimes it's a linear function. And then make sure you include your domain restriction in your number line so important.